morning, folks. Woody from Obadiah's. What you're looking at is the side of a ESSE Ironheart. That's the firebox. This is the panel here that is actually in place. I've removed it. What you're looking at are the fire brick that are the back side of the fire brick that are inside the firebox. And I just wanted to kind of show you the construction of the stove. Those are welds. They're continuous welds. This is heavy gauge steel. The stove itself is totally welded. You have your legs that come down, and the legs are bolted to the bottom of the stove. If you have the pan drawer, you won't have the legs. The stove is bolted to the pan drawer. So this gives you kind of an idea. The only bolted part on the stove is this plate here, which is heavy gauge. The construction of the stove is cast iron and steel. You have a cast iron cooktop called a hob that fits in the center here. You have a cast iron top here. The rest of the stove body is steel. The oven, you can see the very edge right there. It runs all the way around. That is the body of the stove, and the cast iron top itself is sitting on top of that steel plate. That is why the stove is so heavy. The stove has a cast iron doors. All the doors are cast iron. Things that should be cast iron are, the things that should be welded steel are. This is your oven side, and you can see this is part of your convection zone. Once again, everything is welded. These stoves are robotically welded. They're all cut out on a CNC machine. I mean, this is the latest technology. This is probably one of the best constructed stoves out there that I know of. The convection air actually comes out the top edge of the stove. The cold air from the floor gets drawn naturally up into the stove and convected out. There is a heat shield on the side or the back of the stove, and it does the same thing, pulls the cold air up and convects it off the back of the stove. There's an actual air space. I don't know if you can see it. Let's see if we can get the camera angle just right. But the shield is on the back here. Maybe you can see there's a gap here. I'm sticking my finger in it. There's insulation on top between the cooktop itself, or the cast iron top. There's insulation underneath here. So when you shut your lids on your hob, you actually close the heat inside the stove. And if you have the boiler option, you literally transmit the heat out of the stove. You've contained it now, and that boiler will absorb it and move it into another part of the house. Or by shutting those lids, you actually shut down the radiant part of the stove, and it actually will produce more convection heat up the convection zone on either side of the stove and the heat shield on the back. So that's why a little ESSE Ironheart can heat so well. But I just wanted to show you some things on the hob. Mind you, it's backwards. I put it on the wrong way. So the round end is actually supposed to be this way, so the whole hob is supposed to be flipped over. As you can see here, we got fine ash, no creosote at all. That's the hottest part of the fire. Over the hob end, or the firebox, excuse me, the oven side, you can see that there's the stringy creosote stuff. It's almost like got hairs on it. But other than that, there's not a whole lot of creosote buildup in the oven. Nothing's plugged up. Let me get a flashlight, maybe that'll help. Sorry, the lighting's not that great. You can see the hairy things I was telling you about. And there's not a whole lot of creosote, but this is how you get into your stove to clean it out. And I'm going to get into this stove and we're going to clean it out. and while we're doing the boiler, I need to take the side of the firebox out, so figured while I had it apart I would look at it and show you the difference. So the reason that is clean there is it burns hotter than it does over here. What that demonstrates is the importance of a hot fire, and what makes the ESSE burn so clean is the fact that the firebox burns so hot. As you can see, there's hardly any creosote whatsoever built up over the firebox, and normally this end over here would be over there. Like I said, it's upside down. So I'll flip it over and I'll burn it next time the right way, and we'll see what it does. I was told by ESSE it does affect the performance. This is actually engineered to transfer heat, and this is engineered to dissipate heat. And so this absorbs it and moves it over here. So that's what I was told. So we're going to make some changes here. But anyhow, I thought you'd be interested in seeing this. So we're going to pull this out and get it all cleaned up and change out the firebox. So, Woody from Obadiah, we'll talk to you later.